Next one, a battery of voltage is V is connected to 30 watt and 60 watt bulb. Identify the brightest bulb, which bulb having the greatest resistance, and suppose the two bulbs are connected in the series, which bulb will be glow the bright. Okay, this is a diagram. So in this diagram, two bulbs are connected in parallel with the battery voltage. What is the first question அப்படினா identify the brightest bulb. Identify the brightest bulb. So power delivered by the battery, we know P is equal to VI. P is equal to VI. Because of the parallel combination, voltage drop will be same. Voltage drop will be same. So if the voltage will be fixed now, the power is directly proportional to current. Power is directly proportional to current. So 60 watt bulb will be draws twice as much as the current as the 30 watt bulb. So 60 watt bulb alone will be glow brightest. Okay. In the second case, which bulb has the greatest resistance? We know the P is equal to VI. P is equal to, we can write V squared by R. V squared by R. In both the bulb, voltage is same. So power is inversely proportional to resistance. Power is inversely proportional to resistance. It implies that 30 watt bulb will be has the twice the as much as the resistance of the 60 watt bulb. Twice the as much as the resistance as a 60 watt bulb. Okay. In the third question, suppose the two bulbs are connected in series. The current through will be same. Series la connect பண்ணனா the current will be எனக்கு same. Current will be same. Okay. The bulb which has the highest resistance has the high voltage drop. அப்போ resistance அதிகமாக இருக்கும்போது voltage also will be high. So 30 watt bulb will be glow brighter than the 60 watt bulb. Okay. So higher power rating does not always imply more brightness, and it depends upon the whether the bulbs are connected in series or parallel. அந்த ரேட்டை பொறுத்து இருக்காது, whether the connection is series or parallel. Okay, that is a dependent factor. Next one, the two bulbs are marked 20 watt to 220 volt and 100 watt to 220 volt are connected to series to the 440 supply voltage. Which bulb will be fused? Okay. We need to find the voltage. Before that, we need of resistance R. So for the first case, 20 watt to 220 volt resistance R1 is equal to 220 by 20. is equal to 2420 ohm. Okay. In the second case, 100 watt 220 volt. அப்போ R2 is equal to 220 ஸ்கொயர்லையா, அப்போ 220 ஸ்கொயர் பை 100. 220 ஸ்கொயர் பை 100 is equal to 484. Here bulbs are connected in series, so the current which passes through the both will be same. Appa what is the current? Current I is equal to V by R. Appa V is the 440, R is the R1 plus R2. So 440 by and I add pannena we get a 2904. If we multiply it, we get approximately 0.151 ampere. 0.151 ampere. So voltage drop across the 20 watt bulb V1 is equal to IR1. So I is the 440 by 2904 into R is the first R 2420. We get approximately 366.6 ohm. Next, voltage drop across the 100 watt bulb. What is a V2 IR? அப்போ அதே மாதிரி 440 by what is R? 484. Sorry, total resistance R is the 2904 into R. R is the 484. We get approximately 73.3. Okay. அப்போ 20 watt bulb will be fused because voltage rate is only 220 volt. Voltage rate is only 220 volt and 366.6 volt is dropped across it. Okay, அப்போ இது எனக்கு fuse ஆகும் அப்படின்னா 20 watt bulb only fused. Okay. Next, a battery has an EMF is 12 volt and connected to the resistance of 3 ohm. The current in the circuit is 3.93 ampere. Find the terminal voltage and internal resistance, power delivered by the battery and power desired to the resistor. Power desired to the resistor. அப்போ first question terminal voltage. First question terminal voltage. அப்போ V is equal to IR. V is equal to IR. What is the current? 3.93. R is the 3. அப்போ 11.79 volt. Okay. அப்போ terminal voltage கண்டுபிடிச்சாச்சு. அடுத்து internal resistance R is equal to E minus V by V into R. If you substitute 12 minus 11.79 divided by 11.79 into R is the 3, we get 0.05 ohm. 0.05 ohm. First question. Second, third, power delivered by the battery. இப்போ power P is equal to VI. அப்போ 3.93 into 12 is equal to 47.1 watt. 47.1 watt. It is the power delivered by the battery. Okay. இப்போ what is the remaining power? Remaining power is equal to அதிலிருந்து சப்ராக்ட் பண்ணால் கிடச்சி 47.1லேருந்து 46.3 சப்ராக்ட் பண்ணிங்கன்னா we get a 0.772. It is the power delivered to the internal resistance. Okay, and it cannot be used to for the useful work. So terminal voltage, internal resistance, power delivered by the battery, and the remaining power. Okay. Next, from the given circuit, find the equivalent EMF, equivalent internal resistance, total current, potential difference across the each external resistance and potential difference across the each cell. Here 4 cells are connected in parallel. 4 cells are connected in parallel. Upper in the first question, equivalent EMF, that means E total is equal to N epsilon. N as a number of cells is 4. Upper 4 into 9 is equal to 36 volt. 4 into 9 is equal to 36 volt. Next, equivalent internal resistance. Equivalent internal resistance. R is equal to N into small r. N is the 4, small r is the 0.1. So we get 0.4 ohm. Okay. Next, total current. Current I is equal to V by R. Upper total resistance in external plus internal. Upper capital R plus NR. What is the value? 4 into 9 divided by 10 plus 4 into 0.1. Upper if we simplify we get 36 by 10.4. 36 by 10.4. Second question. Potential difference across the external resistance. Upper V is equal to IR. V is equal to IR. That is I is equal to 3.46. R is the 10. Upper 34.6 volt. The remaining 1.4 voltage is dropped across the internal resistance of the cells. Next, potential difference across the each cell. Upper V by N. Total potential number of cells divide panina, we get a potential difference across the each cell. Upper 34.6 by 4 is equal to 8.65 volt. 8.65 volt. Okay. Next question. From the given circuit, find the equivalent EMF, equivalent internal resistance, total current, potential difference across each cell, current from the each cell. There the cells are connected in series. Here cells are connected in parallel. Okay. So in the first question, in the first one, equivalent EMF is equal to 5 volt. In the parallel combination, same EMF தான். And internal resistance, equivalent internal resistance is equal to R by N. R is the 0.5, N is the 4, up 0.125 ohm. 0.125 ohm. Next, total current I is equal to E by capital R plus internal resistance. அப்போ R by N. அப்போ 5 by 10 plus 0.125 equal to 0.5 ampere. 0.5 ampere. Fourth question, potential difference across each cell. V is equal to IR. IS is 0.5, R is the 10. So equal to, we get 5 volt. We get a 5 volt. Okay. Next, current from the each cell. அப்போ I prime is equal to I by N. Number of cells are divide பண்ண கிடைச்சிடும். இப்போ 0.5 by 4 is equal to 0.125 ampere. 0.125 ampere. Okay. Next, from the given circuit, find the value of the I. Using the Kirchhoff first law. Current entering into the junction P is considered as a positive. Away from the junction is considered as the